Yeah, hi everyone. Welcome back to this MC2. In MC2, presently we are discussing about the diuretics. Okay, so diuretics is the part of the anti-anginal topic we have already seen. So in this, in this particular class, presently we are going to be discuss about this thiazide and thiazide like diuretics. Okay, so right. So we have seen in the last class about the outer diuretics definition and classification, and followed by we are going to discuss one by one about the this diuretics, and followed by then in the last class what we have learned about the carbonic anhydrase inhibitors as a diuretics, okay, and how they are going to showing their mode of action to against this carbonic anhydrase inhibitors in the last class. Okay, now in this class we are going to be learned about this thiazide and thiazide like diuretics. Okay, right. So name itself indicating thiazide and thiazide like diuretics. Okay, right. So it's a kind of thiazide and thiazide like is based on the chemical class of compounds. Okay, where it is, and this part is called as a thiazide. Right, it is called as a thiazide part or thiazide moiety. Okay, right. So in this class of molecules, thiazides and thiazide like, okay, basically in the syllabus that are being given about this chlorothiazide, right, chlorothiazide, and followed by the hydrochlorothiazide, and followed by the hydroflumethiazide, and followed by the cyclothiazide, right. So basically the chlorothiazide and thiazide like means like chlorothiazide and hydrochlorothiazide is hydrochlorothiazide and hydroflumethiazide comes under the thiazide like, right. Okay, and it is also like chlorothiazide also comes under the classification of thiazide like. Okay, basically when it comes to thiazides and chlorothiazide and benzothiazide are there, basically in the syllabus they have given about this chlorothiazide, right. So chlorothiazide are the bicyclic molecules having the both this sulfide, okay, is present in the one side the internal ring, and followed by there is amine, and there are some other sulfonamide substitution and chloro substitution at the positions, okay, different position. Okay, so first example is chlorothiazide, because there is a chlorine is at the 7th position, I think, right. In the 7th position the chlorine will be there, and based on that chlorine it's called as the chlorothiazide. Okay, so and it is also given as a star mark asterisk. We need to learn the synthesis of this chlorothiazide. Okay, whereas the hydrochlorothiazide, okay, it's a chlorothiazide derivative, that means derived from the chlorothiazide. Okay, derived from the chlorothiazide, where hydrochlor means they have been reduced the double bond. Okay, right, they have been reduced this double bond. If you reduce the double bond, add the two hydrogens, right. One hydrogen is there and there is one more hydrogen, two hydrogen, that is called a hydrochlorothiazide. Okay, it is a thiazide like diuretic. Okay, whereas the next one is about the hydroflumethiazide. It is also similar. Okay, so the double bond got reduced. Okay, it has been derived from the hydrochlorothiazide. Okay, instead of chlorine substitution we have this CF3 group substitution. Okay, it's a flumethiazide. Okay, CF3 or flumethiazide. Okay, another is cyclothiazide. Okay, instead of it is also derived from the chlorothiazide, that's a thiazide like, and followed by the instead of at this saturated position, correct, at this saturated position you have some cyclic ring, right, the bicyclic ring, so that is called as this chlorothiazide. Okay, so in this we are going to be learned about mainly the mode of action, and followed by the uses of this thiazide diuretics, okay, especially, right. Now we are going to now discuss about the mode of action of thiazide and thiazide like diuretics, chlorothiazide, hydrochlorothiazide, hydroflumethiazide, and cyclothiazide. Okay, right, basically. Now, so we have seen this, right, we have seen in the last class we have discussed about the loop of Henle, right. It's where the uridine production will take place, like, okay, it's called, okay, distal, okay, we have seen this, right, in this last class. Okay, it is about the Bowman tubule, not a loop of Henle, it's a Bowman tubule where the production of urine will take place. Like we have a PCT, like proximal convoluted tubule, and followed by the loop of Henle. Okay, and okay, it's a PCT and followed by the loop of Henle, like loop of Henle, and followed by the distal convoluted tubule, DCT, right, and followed by the ductile tube. Okay, So we have seen that the this carbonic anhydride, they are acting at the DCT, right? After that, okay, so these thiazide diuretics, they are acting on the site of action at the DCT. Okay, it is called the distal convoluted tubule. Okay, so this is called the early stage of distal convoluted tubule, right? This is called the early stage of distal convoluted tubule, where the thiazides, they are showing their mode of action. Okay, is at the early stage of the distal convoluted tubule, early stage of distal convoluted tubule, and this is where this is the site of action in the Bowman tubule. Okay, site. So the site of action of these thiazide and thiazide-like diuretics are showing their site of action at the distal convoluted tubule, DCT, that is at the early stage of DCT. Okay. Now what happened at the early stage of DCT? What are there? There are sympoters. Okay. So this is where the transportation of the inside and outside, the transportation of water along with the sodium, potassium and chloride ions we have seen in the last class. Okay, in detailed explanation. Okay. Now here what will happen? So there is a kind of specialized enzymes called NaCl transporters, like Na plus by Cl minus co-transporters, otherwise as okay, NaCl, Na plus and Cl minus co-transporters as well as sympoters, these are called. Okay, what is their main role of? They used to be involved in the absorption and reabsorption of both sodium ions and chloride ions. Okay, from the this DCT. Okay, there is a exchange of this sodium and potassium along with the chloride ions will take place, like inside outside this DCT. Where these are the location of this NaCl and Cl, Na plus by Cl minus sympoters. Okay, the thiazides and thiazide-like diuretics like chlorothiazide, flumethiazide, and followed by the cyclothiazide. Okay, so hydrothiazide. Okay, they are showing their mode of action by acting on by inhibiting this Na plus by Cl minus sympoters. Okay. So what will happen? Okay, thiazides are there inhibiting they are showing this their mode of their mechanism of action by inhibiting this Na plus Cl minus sympoters on the early stage of this DCT. Okay, so yeah, DCT, there is a collecting duct, right? There is transport. The moment when you have this inhibit this NAs, this sympoters, what will happen? The reabsorption of Na plus and water molecule will ceased or stop up to the certain extent, right? So here, right? So what will happen? The sodium ions will be loss will take place along with the urine, including the water. Okay, so the enhanced sodium plus dilute results the K plus ions loss in the collecting duct. Okay, there is a K plus ions. The K plus ion concentration will increases. Okay, usually more than around 10% of the filtered sodium is reabsorbed in the distal convoluted tubule. Okay, whatever the sodium ion will be reabsorption will takes place into the distal convoluted tubule. That's where we are going to be stopping this sodium reabsorption by inhibiting this sodium and NaCl sympoters. Okay, right. Now because thiazide diuretics, okay, there is a loss of NaCl and water will takes place. Okay, because of the thiazide diuretics, the loss of Na plus ions increases indirectly increases the potassium ion concentration. That leads to the condition called hypokalemic metabolic alkalosis, or that means hyperkalemia. Okay, what we used to call generally, that means increase of the potassium ion concentration, and followed with increase of calcium plus 2 ions reabsorption also will take place indirectly by this inhibition of this Na plus and Cl minus transporters. Okay, now we are going to learn one by one how exactly this showing the mechanism of action of this thiazide and thiazide-like diuretics, right? The diuretics effect of the thiazides is related to their ability to inhibit the Na plus and Cl minus sympoters. Okay, Na plus and Cl minus sympoters. Okay, right. Yeah. So Na plus and Cl minus sympoters. Okay. Okay. Now located at the early segment of or early stage of DCT, right? It's a distal convoluted tubule. Right? So by the inhibition of Na plus and Cl minus sympoters by thiazides. Okay, thiazides. Okay. What are the thiazides given in the syllabus mostly? So add to the reabsorption of Na plus and Cl minus, add to the Na plus and Cl minus reabsorption, and decrease and followed by the enhances the urine excretion of both water and Na plus ions. Okay, enhances the excretion, urine excretion with the both including with the water and Na plus. Right. So thiazide like chlorothiazide. Okay, what we have seen, and followed by the hydrochlorothiazide and hydroflumethiazide, and followed by the cyclothiazide. Okay, not four. Okay, they are shows their similar kind of mechanism of action, but duration of action will varies. Okay, only thing is the duration of action of these derivatives varies. Okay, not only these four has been given in syllabus, apart from like benzyl thiazides also will be there. There also shows the similar kind of mechanism of action. For acting as a diuretics. Right. Yeah. Now we are going to learn one by one thiazide diuretics given in syllabus and their uses specifically. Okay. So first one is about the chlorothiazide. We have seen the structure, right? We have it's a chlorothiazide derivative. There is a chlorine substitution in this position, right? I think next position, and followed by the sulfonamide. Okay, the sulfonamide also very important. That must be also in the free. That must be also be in the free form. Okay, right? And here, right, chlorothiazide is sold under the brand name of diuryl. Okay, so diuryl, and especially used as a diuretic and as an antihypertensive agent. Okay, antihypertensive. Okay, so along with the as such, used as a diuretic as well as the hypertensive, along with the combination of other antihypertensive drugs. Okay, to remove the sodium ion pulse concentration. Okay, in the body. Right. Next is about the hydrochlorothiazide. Right. This is about the hydrochlorothiazide. Okay, where in the hydrochlorothiazide, okay, it's a derived from the chlorothiazide. Okay, basically only thing is the reduction of this double bond leads to the reduction of the double bond on the chlorothiazide leads to the hydrochlorothiazide. Okay, but the reduction of the double bond play important role in the SCR activity. So SR specifically not mentioned to be here to be studied especially, and that reduction of double bond leads to the increase of this diuretic activity. Will leads to give the one type of special hydrothiazide class of diuretics, otherwise thiazide like class of diuretics, right? So especially this hydrochlorothiazide will have a also a very highly used diuretic. Basically hydrochlorothiazide used to be treat the like high blood pressure, high BP, hypertension, and congestive heart failure, and symptomatic edema, and followed by the swelling due to the fluid buildup. Okay, if you have any kind of swelling because of the fluid buildup, used to be cured by this hydrochlorothiazide. Yeah. Okay. Next is about the hydroflumethiazide. Okay, so it is also derived from the comes under the class of hydrochlorothiazide. Instead of chlorine, we have a different substitution called CF3 group. Okay, remaining almost every structure is almost same. Only instead of chlorine, we have the CF3 group. Okay, that's why it's called as a flumethiazide. It is called as a fluoromethyl group. It is called as a fluoromethyl group. Only the change, the structural change is about this fluoromethyl group. Okay, where only the Cl is replaced by CF3. Okay, now what will happen? It is also one of the important class of hydrothiazide derivatives. Okay, where this hydroflumethiazide is a thiazide diuretic used to treat the hypertension as well as edema. Okay, so hypertension is treated by this hydroflumethiazide. It is also very well-known drug for the used for the usation of CHF, congestive heart failure, and followed by the liver cirrhosis. Also can be used for, okay, for this one. Next one is about the cyclothiazide. Okay, right. Cyclothiazide. Okay, here it is also derived from this hydrochlorothiazide. Okay, and having with the same double bond will be reduced, and there is a chlorine will be there. Apart from that, okay, one of the reduced carbon is attached with this bicyclic ring. Okay, bicyclic ring. That's why they have given as a cyclo, given in the thiazide. Okay, it is called cyclothiazide. So cyclothiazide is used as a injective therapy in the edema associated with the congestive heart failure, CHF. Okay, and hepatic cirrhosis also can be treated by using this cyclothiazide. It is also enhances the effectiveness of the other antihypertensive drugs in the more severe form of hypertension. If you have anybody felt with the more suffering with the more severe hypertension form, they used to give the combination of hypertensive drugs along with the combination of this cyclothiazide as an important use, right? So we have learned the whatever the drugs mentioned as a diuretics, especially in the thiazide class. We have been learned the their mode of action and followed by their uses one by one specifically. Okay. After that, okay, so we have given about the synthesis of this chlorothiazide, right? So synthesis of chlorothiazide, we know that, right? So synthesis of chlorothiazide is a drug to be especially given to learn about the synthesis, okay, which is indicated in the form of star mark, right? So now chlorothiazide is a well-known, very familiar structure. We have seen the structure of chlorothiazide, where it is having this thiazide like moiety. We are having the chlorine substitution and followed by the free sulfonamide substitution will be there, right? Yeah. Now how to synthesize this chlorothiazide? Okay. For synthesizing this chlorothiazide, okay, so we need to require the starting material is about the 3-chloroaniline. Okay, 3-chloroaniline, right? 1, 2, 3, 4, 5, 6, right? So 3-chloroaniline is a starting material. When you react this 3-chloroaniline with this chlorosulfuric acid, okay, right? Sulfonic acid, it's sulfuric acid derivative is a chlorosulfuric acid. Okay, so when you do like reaction with this in between 3-chloroaniline and chlorosulfuric acid, it will undergo the sulfonylation. Okay, undergo the sulfonylation. It will form the sulfonyl chloride. It will form the sulfonyl chloride. Okay, and at the two substitutions, okay, both 4th and 6th position, right, has been substituted with this undergo the sulfonation. It will be the sulfonyl chloride derivative. Sulfonyl chloride derivative, where like it will form the 4-amino 6-chlorobenzene 1,3 disulfonyl chloride. Okay, and when you have reacted this this derivative with the ammonia, okay, ammonia gas, okay, so whatever the chlorine substitution now replaced by this ammonia substitution, it will give the sulfonamide substitution at the 4th and 6th position. Okay, we get the both sulfonamide. Okay, the chlorine is now undergo the nucleophilic substitution with the ammonia molecule. It will give the sulfonamide and sulfonamide. Okay, now 4,6 sulfonamide amido 3-chloroaniline, it will give as a derivative. Okay, which is on this derivative, this 4,6 sulfonamide derivative of this chloroaniline derivative now react with the formamide. Okay, it is about the formamide derived from the formaldehyde and followed with the ammonia to the formamide. Okay, if you react with this formamide with this above obtained derivative, it will undergo the cyclization. It will undergo the formamide undergo the cyclization in between the sulfonamide and this amine, and leads to form the thiazide derivative. Okay, which is also having this chlorine substitution. Okay, right? This chlorine is already comes from this 3-chloroaniline. Okay, so it will give this chlorothiazide derivative, right? Okay. Likewise, likewise, we have learned the synthesis of this synthesis of this chlorothiazide.